Here's a list of topics for Chapter 3. I will let you read through those. The first topic, as you could have seen, was the three laws. Now, the first one you likely are quite familiar with, the law of conservation of mass. It just states that mass is neither created nor destroyed during a chemical reaction. You've all had 9th grade science, so I know you've all heard this one at least once before, probably more than once. It basically means what goes in must come out, or what comes out something must have gone in to get that thing out. Matter is not just conjured up out of thin air, and matter doesn't just disappear into thin air. Every chemical reaction, even though it looks like something might magically appear, it's probably coming from the gases in the air. It's solidifying from the gases. But all matter can be accounted for before and after. So a simple way to put that is that the mass of the reactants equals the mass of the product. So you don't just get mass appearing out of nowhere. It comes from matter that's already here. So an example, here's a chemical reaction. If you count all the atoms that are going in, and let's switch to a pen here. If you count the carbon atom as the black, there's one carbon atom that goes in, one that comes out. There's 4 oxygen atoms that go in. If you count 1, 2, 3, 4, there's 4 oxygen atoms that come out. So 4 go in, 4 come out. Same thing, there's 4 hydrogens, the gray ones there that go in, 4 hydrogens that come out. So whatever goes in comes out. You don't get any extra hydrogens. It's not like we have any extra hydrogens over here that are just appearing out of thin air. Everything on this side can be matched up to something on this side. The second law, this one you probably haven't heard, the law of definite composition or definite proportions, says that a given compound will always be found in the same proportions or the same ratio. So the ratio of the elements is always the same. An example is sugar. Sugar has, as you can see here, 42% carbon, 51% oxygen, and 6.5% hydrogen. And if you take any sample of pure sugar, it will have that exact same ratio. That's what the law of definite composition says. It says if you have sugar, it will be found in this exact ratio. You can go all the way across the world, find more sugar over there, same exact thing. It's not like sugar is different in composition depending where you get it from. Now, if you have a different type of sugar, that's another thing. But another way to put that is the formula is always C6H12O6. Another example is water. Water is always H2O. You're never going to see water as H3O or HO. And it's always 11% hydrogen, 89% oxygen by mass. Again, if you go all the way across the world, take a sample of water, purify it, it's going to have this exact same ratio. That's what the law of definite composition means. And if you remember from Chapter 1, we talked about mixtures. Mixtures do not have a definite composition. A mixture of sand and salt could be a 50-50 mixture, a 75-25 mixture, a 10-to-1 mixture. The mixtures, the composition can vary, but compounds, they do not. The last law is the law of multiple proportions. This one gets confused with the previous law, but it is quite different. It says that elements can combine in different whole number ratios, and it's proposed by Dalton. What that means is carbon and oxygen. Let's say I have 2 elements. I have carbon, I have oxygen. These 2 elements are not restricted to forming just one type of compound. They don't just form one compound only. They can actually form multiple different types of compounds. They can form in a 1-to-1 ratio. They can form in a 1-to-2 ratio. I think there we go. I already have that listed. So the multiple proportions means that these 2 elements can combine in different ratios, a 1-to-1 or a 1-to-2 ratios. If you take organic chemistry, you work with a lot of compounds that are made of carbon, hydrogen, and oxygen. These 3 elements can form literally thousands and thousands and thousands of different compounds in different ratios. Many different compounds can be made by that. So that what it means is that 2 elements aren't restricted to just forming one compound when they combine. They can form different compounds with different ratios of elements of them. So that's the difference between the second law and the third law. If you're a little confused, go back, watch the second law again. make sure you understand the difference. If you don't, bring any questions you have to class.